we have to study dielectric and polarization. To study dielectric, we must know few points. So first is, what is conductor? The material through which electricity can pass easily are called conductors. Why electricity can pass through these materials? Because they contain free charges. That is electrons. Such a material contains large number of free charges or large number of free electrons inside it. These electrons are valence electrons, which are loosely bounded to nucleus. Hence they can move randomly inside the metal. When electric field is applied across such a material, then electrons move in a direction opposite to applied electric field and current can flow through such a material. These materials are called conductors. What is the meaning of free charges? We will see some properties. Properties of conductor. Under electrostatic condition. Electrostatic condition means charges on that material are stationary or at rest. Then the electric field inside the material is zero, means net electric field in the interior part of conductor is zero. What about electric potential of such a material, of such a conductor which is in electrostatic condition? So electric potential is constant. In interior part or on the surface of conductor, electric potential is constant. What about electric charge? And charges are not moving, they are stationary. Hence, net electric charge in the interior part of conductor is zero, or there is no electric charge, net electric charge in interior of conductor or inside the conductor. Electric field intensity. If you take a point near the surface of charged conductor, the electric field intensity is always perpendicular to surface of charged conductor. Means E is always perpendicular to the surface. And last, what about charges on the surface? Surface charge density, sigma, it may be different at different point because charges are spread. Depend upon the nature of material, it may be uniform or it may not be uniform. Therefore, surface charge density is different at different points. So this is about conductor. So conductor means material which through which electricity can pass easily is called conductor because they contain free charges. Free charges means they are valence electrons which are loosely bounded to nucleus. Hence they can move randomly inside the metal in the absence of electric field. But when electric field is applied, they move in a direction opposite to applied field and current can flow through such a material. When charges on a conductor or material are stationary, they possess some properties. First property is electric field inside the conductor is zero, net electric field. Electric potential on the surface of conductor or inside the conductor is constant. Net electric charge inside the conductor is zero, or there is no electric charge, net electric charge inside the conductor, and electric field at any point near the surface of charged conductor is always perpendicular to surface of conductor. And how charges are spread on it? So surface charge density may be different at different point, or may be same. Now we'll see another term. What is meaning of free charges and bound charges? We know electron in atom is positively charged. Nucleus in the atom is positively charged, and negatively charged electrons are revolving around it in different circular orbit. The electrons are tightly bounded to nucleus, which are in inner orbit of atom. But electrons which are in outermost orbit are loosely bounded to nucleus. So these charges or these electrons are called free electrons. They can move randomly inside the metal. But electron in the inner orbit are very strongly bound to nucleus, that they cannot move. The electrons which are in outermost orbit, that is valence electron, are free to move inside the metal. Hence, these charges are called free charges. Electron in inner orbit are very tightly bounded to positive charge on the nucleus. Hence, these negative charges and these positive charges cannot move. Therefore, charge on the nucleus and charge of electron in the inner orbit are called bound charges. Whether positive charges and negative charges both act as a charge carrier in conduction of electricity, but these bound charges cannot move due to strong force of attraction. What is meaning of insulator? So conductor contain large number of free charges or electrons, but in insulator all electrons are tightly bounded to nucleus, means there are no free charges, means no current flows through them. Its electrical conductivity is very low. Such materials are called insulators. Now we can study what is meaning of dielectric. So dielectrics are insulators. Means there are no free charges, no free electrons in it, but the materials which can be used to store electrical energy. are called dielectrics. All insulators are not dielectric, but the insulators which can be used to store electrical energy are called dielectrics. When such dielectric is kept in external electric field, then due to stretching of charges, positive charge and negative charge are stretched. Positive charge is stretched in direction of electric field. It is like this. If you consider this is dielectric material and kept in external electric field, then negative charge is stretched in opposite direction, positive charge is stretched in direction of electric field. Due to this stretching, net electric dipole moment is produced in such a material. Such a material is called dielectric. So dielectric means when electric field is applied across insulator due to stretching of charges, net electric moment is produced in material. Such a material is called dielectric, and this phenomenon is called polarization. Means production of electric dipole moment in a material due to application of electric field is called polarization. Now we will see atom contain positive charge nucleus and a cloud of negative charges, that is electron, is around it. So inside nucleus there are positive charges and electrons, they are negative charge. So all these electrons are revolved around the nucleus in different orbit around nucleus. So all these charges on the nucleus will be concentrated at a point. It's called center of mass of negatively charged electron. Similarly, all positive charge on the nucleus is concentrated at a point is called center of mass of positive charge. If these 2 points are separated by a certain distance, then such a molecule or atom possesses electric dipole. Center of positive charge do not coincide with center of negative charge. Therefore, it possesses electric dipole. Such a molecule is called polar molecule. Or substance is called polar substance. So which is polar substance? In the center of positive charge of nucleus do not coincide with center of negative charge of electron, then such a material possesses an electric dipole, and such a molecule is called polar molecule, and substance is called polar substance. For example, if you take water molecule. So this is oxygen. O, EH and H. So this is OH1 and this OH1. They are separated by 105 degree. So it possesses electric dipole like this. Electric dipole moment. Similarly, we can write HCl is another example of polar molecule. If this is EH and this is Cl. So H2O, HCl are polar molecule. We represent it like this. This is the center of negative charge minus and center of positive charge plus. They are separated by certain distance. This is called a polar molecule. But in some materials, center of positive charge of nucleus coincide with center of positive charge on the nucleus coincide with center of negative charge on the electron. Then such a molecule do not possess electric dipole because positive charge and negative charge coincide at the same point. Such a material or such a molecule is called non-polar. If you consider EH2, O2, En2 are polar molecules. Like this. If this is hydrogen atom, another hydrogen atom, does not possess electric dipole. This is O2. We represent polar molecule like this. We draw a circle. And this is pair. This is center at which both positive and negative charges are coincide. So these are non-polar molecules and these are polar molecules. In polar molecule, center of positive charge and center of negative charge are separated. In non-polar molecule, center of positive charge coincide with the center of negative charge. They do not possess electric dipole moment. Now we study when these polar or non-polar molecules are kept in external electric field, how they behave. So you see, polarization of non-polar molecule in external electric field. If we consider a non-polar substance, if there is no external electric field, then we can represent like this. E is equal to 0. There is no external electric field, then polar molecules are represented like this. All these are non-polar molecule because center of positive charge and center of negative charge are coincide at a point. They do not possess an electric dipole moment. This substance do not have net electric dipole moment. When it is kept in external electric field, then due to effect of applied field, E is non-zero, is not equal to 0 if direction of electric field is like this, from left to right. Then these positive charges are repelled by this field. Negative charges are attracted in opposite direction, means due to stretching of charges, the center of positive charge and center of negative charge get separated from each other. So it is like this. This negative charge get attracted towards left side or in direction opposite to applied field. Positive charge gets stretched in the direction of the field. We will represent all molecules like this. Negative charges on the left side, positive charges on the right side. So when extra electric field is applied, electric dipole moment is produced in each molecule. Thus this substance acquire net electric dipole moment. So this is about a non-polar molecule when kept in extra electric field. Now we will see polarization of polar molecule in external electric field. In the absence of external electric field, polar molecules are represented like this. They possess electric dipole, but their moments are randomly oriented different direction So that net electric dipole moment of substance is 0 and extra electric field is not applied equal to 0. When electric field is applied across the polar molecules, all electric dipole moment rotates and becomes parallel to the field. If electric field is applied in this direction, it is non-zero, is not equal to 0. Due to this, substance acquire net electric dipole moment and it get polarized. It also possesses net electric dipole moment. It's both non-polar and polar molecules are kept in extra electric field. They acquire net electric dipole moment. The electric dipole moment per unit volume is called polarization. Net electric dipole moment per unit volume is called polarization. We can write formula polarization P equal to Psi into E, where E is external electric field and Psi is electrical susceptibility of given material. It gives the behavior of material in the electric field, hence it has different values. For different material, Psi is equal to 0 for vacuum. So this is about polar and non-polar molecule when kept in external electric field. Thank you.